Hi friends, this is Naresh. In this class, I am going to explain about centroid of an C and U sections. This is my fourth class. First of all, you have to know the centroid of a rectangle. The centroid of a rectangle lies at half of the base and half of the height. Now look at the problem. Locate the centroid or center of gravity of the given C section. The given figure is here. First of all, the given C section is split up into three rectangles. That is, bottom horizontal rectangle as first section. The dimensions of a rectangle 1 is base B1 equal to 100 mm and D1 depth D1 equal to 20 mm, and the second rectangle is vertical 1. The dimensions are base 2 equal to 20 mm and depth or height D2 equal to 60 mm, and third rectangle is base 3 equal to 120 mm and depth D3 equal to 10 mm. Now I am considering the reference plane, reference axis, that is the x-axis at the bottom edge and y-axis at the left side edge as shown in figure. Now coming to the areas, the area of a bottom rectangle A1 equal to B1 into D1, that is 100 by 20 equal to 2000 mm square. This is area 1. The area of a rectangle, yellow rectangle, B1 into D1. Next, the area of a second rectangle is B2 and D2. So the area of a second rectangle is B2 into D2, that is 20 by 60 equal to 1200 mm square, and the area of a third rectangle is B3 into D3, that is 1200 mm square. 120 by 10 equal to 1200. So 120 mm B3, D3 equal to 10 mm. So B3 into D3 equal to 1200 mm square. Now x-axis, y-axis, origin O. Now I am drawing the diagonals to locate the individual centroids. C1 is the centroid of a bottom rectangle at a distance of x1 from y-axis and y1 from x-axis. Here x1 equal to base by 2, y1 equal to depth by 2, d1 by 2. Now C1 is the centroid of a bottom rectangle. Now I am drawing the diagonals of a second rectangle to locate the centroid C2. Now C2 is at a distance of x2 equal to b2 by 2 from y-axis, and y2 equal to d1 plus d2 by 2 from x-axis. Now I am drawing the diagonals for third rectangle to locate the centroid C3 at a distance of x3 equal to base 3 by 2 and y3 equal to d1 plus d2 plus d3 by 2. So therefore from diagram x1 equal to 50 mm, x2 equal to 10 mm, x3 equal to 60 mm. Now y1 equal to d1 by 2 equal to 10 mm, y2 equal to 20 plus 30 equal to 50 mm, and y3 equal to d1 plus d2 plus d3 by 2 equal to 85 mm. These are the values. Now these values are written in tabular form in next slide. From general expression, x equal to the distance of centroid or center of gravity of the entire C section from y axis, yc equal to the distance of centroid or center of gravity from x axis. Now x equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Answer is x equal to 41.81 mm. Now similarly, y is equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Answer is y is equal to 41.36 mm. So now in the next slide I am showing the final position of a centroid or center of gravity. This is the given figure. C1, C2, C1, C2, C3 are the individual centroids, whereas CZ is the centroid or center of gravity of the entire C section at a distance of xc from y axis and yc from x axis, where answer is x equal to 41.83 and yc equal to 41.3. This is the final location of the centroid for a C section. In similar way, I want to find the centroid or center of gravity of a U section. These are the dimensions for U or channel section. U section or channel section. Now, first of all, the given section is split up into three small rectangles. That is bottom rectangle as a section 1. The dimensions are base 1 b1 equal to 100 mm and d1 equal to 20 mm. Now second section is left side vertical rectangle. Dimensions are b2 base 2 equal to 20 mm and height d2 equal to 60 mm. And the third section is vertical right side rectangle. The dimensions are height d3 equal to 60 mm and base b3 equal to 20 mm. Now I am taking the x-axis at the bottom edge and y-axis at the left side edge. O is the origin. Now I am locating the individual centroids for these three rectangles. Now I am drawing the diagonals to locate the individual centroids. C1 is the centroid of a bottom rectangle at a distance of x1 from y-axis and y1 from x-axis, where x1 equal to base by 2 and y1 equal to d1 by 2. Similar way, I am drawing the diagonals for a second rectangle to locate this C2, centroid C2 at a distance of x2 equal to base 2 by 2 and y2 equal to d1 plus d2 by 2. In similar way, C3 is the centroid of a third rectangle at a distance of x3 equal to b1 minus b3 by 2 and y3 equal to y2 equal to d1 plus d2 by 2. These are the values, and these values are written in tabular form in next slide. From general expression, by substituting these values, we will get the final answer x equal to 50 mm and y equal to 31.81 mm. Now I am showing the final position of the centroid or center of gravity for channel section. C1, C2, C3 are the individual centroids, whereas CZ is the final centroid or center of gravity of a entire U section at a distance of xc equal to 50 mm and yc equal to 31.81. Now in similar manner, I want to locate the centroid or center of gravity of a unsymmetrical channel section. It is same as before problem. Now first of all, the given section is split up into three rectangles, that is section 1 B1 equal to 100 mm, D1 equal to 20 mm, and the second rectangle is base 2 equal to 20 mm and D2 equal to 60 mm, and third rectangle is D3 equal to 80 mm and B3 equal to 30 mm. Now I am taking the x-axis at the bottom edge and y-axis at the left side edge. O is the origin. Now I am drawing the diagonals to locate the individual centroids. Where C1 is the centroid of a bottom rectangle at a distance of x1 equal to base 1 by 2 and y1 equal to d1 by 2. In similar way, C2 is the centroid of a second rectangle C2 at a distance of x2 equal to b2 by 2 and y2 equal to d1 plus d2 by 2. Now I am drawing the diagonals for third rectangle to locate the C3 at a distance of x3 equal to total base b1 minus b3 by 2 and y3 equal to d1 plus d3 by 2. These are the final values. Now these values are written in tabular form. By substituting these values into general expression, we will get the final answer. X equal to 56.42, whereas yc equal to 40 mm. Now I am locating the final centroid CZ. C1, C2, C3 are the individual centroids, where CZ is the centroid or center of gravity of a entire U section at a distance of xc equal to 56.42 mm from y-axis and yc equal to 40 mm from x-axis. This is the final position of a centroid or center of gravity of an U section. Thank you.